Welcome to this video, where you will learn how to install and access the robot sensor interface inside iiQKA OS2 using iiQWorks.Cockpit and iiQWorks.Sim. This step is important for virtual commissioning, because it allows you to monitor and validate sensor-based robot behavior in a simulated environment, exactly as it will later work on a real robot controller. First, open iiQWorks.Cockpit. On the main screen, navigate to the software repository. You can find it in the bottom left area of the cockpit interface. The software repository is the central place where you manage optional software packages for both simulation and real commissioning. Now select the Robot Sensor Interface option package and install the version you need. In most cases, you should choose the latest available version to ensure full compatibility with iiQKA OS2. During installation, you must also select where the software should be installed. You can choose between different targets, such as iiQWorks.Cockpit or iiQWorks.Sim. If you are working with a virtual robot controller for virtual commissioning, make sure you select the correct iiQWorks.Sim version that matches your setup. After selecting the correct target and version, start the installation process. The installation may take a short moment. After it is completed, you need to restart both iiQWorks.Cockpit and iiQWorks.Sim. This restart is required so that the new software package is fully registered and available in the user interface. Once iiQWorks.Cockpit has restarted, look at the bottom left area of the interface again. Here you will find a plus icon that allows you to add new option packages, extensions. Click on this icon to access the available extensions. After the installation, you will now see a new entry for the RSI Monitor. You will use this RSI Monitor at a later stage to observe and validate sensor-based robot motion during virtual commissioning. Now let's continue in iiQWorks.Sim. Open iiQWorks.Sim and navigate to the eCatalog. From there, switch to the eCAD section of the iiQWorks.Sim library. Open a robot model in the simulation. You can either load a new robot or reuse the robot that is already part of your current layout. Once the robot is loaded, click on it in the 3D scene. On the right-hand side, you will now see the robot properties. Next, open the eCAD section and look for the measuring tip. You can snap the measuring tip directly to the robot. Attach it to the robot flange and home attach. This ensures that the measuring tip moves correctly together with the robot. Now click on the robot again and open the available options. Here you should find the Robot Sensor Interface option package that you previously installed using iiQWorks.Cockpit. Select this option and add it to the robot by clicking on plus and then validate the change with OK. After adding the option package, navigate to the Home tab and in the lower left corner open the Devices section and in the option packages select the iiQKA Robot Sensor Interface. On the right-hand side, you will now see additional configuration options inside the option packages of the robot controller. Select the iiQKA Robot Sensor Interface and open the Examples section. Here you will find predefined example configurations that are included with the option package. To import an example, click on the small import icon. This allows you to load content from a repository. Paste the provided path into the context field and confirm the import. In this video, we import the circle correction example. It will be added directly to the context and becomes available for use. Now switch to the Program tab of the robot. Here you can either create a new program or import KRL files directly from the example package. When you import an example, a new program will automatically appear at the bottom of the program list. Open this program and take a moment to review it. This program loads and activates the RSI project called RSI_Circle Core. It generates a sinusoidal circular motion around the current robot position using Lissajous behavior. The motion is created exclusively through RSI corrections in the Y and Z directions. First, the path runs once with full amplitude and then a second time with half the amplitude. Please also visit Expert for a clear overview of how the robot sensor interface logic is integrated in the program. Next, add a new tool. In this case, we use Tool Data 1. You will also configure an output signal, for example output 17, which, once set to true, will visualize the TCP path of Tool Data 1. Now open the jog mode of the robot. Select Tool 1, previously defined. Use the snap functionality to align the tool correctly to the measuring tip. After that, open the Configuration tab and navigate to the KRL Executor. Select the Virtual Robot Controller as the execution target. Inside the Virtual Robot Controller settings, select the local host and create a new instance. Give this instance a meaningful name. In this example, we call it RSI Test Instance. Click on Deploy Configuration onto Controller. Now save the complete layout under a new name. After saving the layout, and make sure to select the same instance name as previously defined, iiQWorks.Sim will generate the same code structure that would be deployed to a virtual robot controller running iiQKA OS2. Once the layout is saved, activate the virtual robot controller instance running on the local host. When the virtual robot controller is ready, go back to the Program tab. Select the RSI Circle Correction program and activate it. Then start the simulation using the play button. The virtual robot controller will now start, and the robot motion is executed inside the simulation. At the same time, open iiQWorks.Cockpit and navigate to the RSI Monitor. In the RSI Monitor, you will see the RSI test instance. A sinusoidal signal is generated. This signal is loaded into the correction object POSCORE as a sine function in the z direction, and again, with a delay, as a sine function in the y direction. Following the first execution of the signal processing, the amplitude of the signal is subsequently modified in the KRL program. When the signal processing is started again with half the amplitude, a smaller circular motion is obtained. The robot is controlled purely by means of corrections on the basis of the absolute correction values in the y and z directions. After a defined time, the sensor-guided motion is aborted by means of a timer. This confirms that the sensor-based correction is active and working as expected. This concludes the first showcase of an example from the Robot Sensor Interface in iiQWorks.Sim using iiQKA OS2. The same workflow can later be applied to a real robot controller.
Thanks for tuning in. We appreciate your support. Make sure to subscribe to the KUKA channel for the latest updates and tutorials. For hands-on experience, check out the KUKA College. Until next time, and keep learning and simulating.
Making automation easier.